In the beginning, there was the internal combustion engine, a marvel of modern technology. Rather than using the external combustion and pressurizing steam to create locomotion like its predecessors, internal combustion engines utilized a state-of-the-art refinery product called gasoline. The first internal combustion engines would be almost unrecognizable as a means of transportation to us today. With a handful of parts and little to no air intake filtration, it was common practice to disassemble, clean, and repair an engine relatively simply. These early engine configurations and ease of breakdown helped to overshadow the looming long-term effects of carbon as a combustion byproduct that can rob an engine of its efficiency and power. In their defense, it's easy to be short-sighted when the alternative is sitting downwind of a horse's behind on a 3-hour trip into town. Fast forward to the modern day, where engines have begun to more resemble server farms than covered wagons, and the ease and cost of breakdown to clean carbon deposits is prohibitive for all but an experienced technician themselves. But how, with all this wonderful technology, has the persistent issue of carbon buildup inside an engine been solved? Put simply, it hasn't. Carbon, and its detrimental effects on key engine components, has fallen victim to modern disposable culture. A component slowly builds a layer of carbon, begins to operate suboptimally, causes knock-on effects for other systems, eventually fails, and is replaced for a handsome fee, while the vehicle itself spends days or weeks at the shop. If these components happen to be turbochargers or diesel particulate filters that are now standard on late model engines, this will cost the customer thousands in repairs without accounting for downtime. This is exactly the problem that hydrogen carbon cleaning, and specifically HHO, aims to solve. By adding hydrogen gas to an engine's combustion equation by way of the air intake system, combustion temperatures, along with blast speed, increase, causing a phase change in built-up carbon molecules, returning them to a gaseous state. Freed carbon molecules can then be evacuated through the engine's exhaust system without causing further damage. This process uses no harsh or hazardous chemicals, reduces engine emissions going forward by returning efficiency, and ultimately saves the customer on fuel and cost of repair. The only thing more impressive than HHO's benefits to customers are unit economics, low overhead, and 98.5% gross profit margins. More on those things to come. Thanks for watching.